All right, what I'd like you to do here is factor these quadratics. So think about numbers that multiply to c and add to b. Pause it, give it a try. Okay, we're back. Here, our c value is 15, our b value would be 8, so the numbers that multiply to 15 and add to 8 would be 5 and 3, so our factors would be x plus 5, x plus 3. For number 2, we'll have x plus 8, x plus, sorry, that's not correct. We'll have x plus 7, x plus 4. For number 3, we'll have x plus 11, x minus 2. And then we'll have x plus 5, x minus 5. This one's kind of tricky. Notice our c value here is negative 25. Our b value, we don't have any x's, so our b value would be 0. So we'd look for two numbers that multiply to negative 25 and add to 0, which in this case is 5 and negative 5. Okay. All right. So as we look at this next problem, factor the following quadratic: x squared plus 9x equals plus 18 equals 0. Again, we want to factor this out. So look for numbers that multiply to c, add to b. So the numbers that would multiply to 18 and add to 9, those would be 6 and 3. Okay. So those would be our factors. What I'd like you to do here is plug in each of these x values in to the equation. So, like what we'll do here, we're going to plug in 2 for x. So we'll have 2 squared plus 9 times 2 plus 18 equals 0. Simplify, 2 squared is 4, 9 times 2 is 18. So we have 4 plus 18 equals 0. 4 plus 18 is 22. Plus 18 is 40. Okay, so we get 40. I want you to do the same thing for those other 3 x values. Pause the video, do that on your own. Okay, we're back. Here, we'll plug in 4 here, so we get 4 squared plus 9 times 4 plus 18 equals 0. And 4 squared is 16, 9 times 4 is 36, plus 18 equals 0. From there, 16 times 18 is 52, plus 18, 70. Okay, for negative 6, so we got negative 6 squared plus 9 times negative 6 plus 18 equals 0. Negative 6 squared is 36. 9 times negative 6 is a negative 54. 36 minus 54 is negative 18. Negative 18 plus 18 is 0. For negative 3, the last one, negative 3 squared plus 9 times negative 3 plus 18 equals 0. Negative 3 squared, or negative 3 times negative 3, would be positive 9. 9 times negative 3 is negative 27. 9 minus 27 is negative 18. Negative 18 plus 18 is 0. Okay. So, what we did here was we started by factoring, and we got x plus 6 times x plus 3. Notice here, when we plug in some numbers, we plugged in 2, 4, negative 6, and negative 3. When we plug in negative 6 and negative 3, we get 0. Or in other words, those numbers make this function equal to 0. They check out, they work. How are these related to x plus 6 and x plus 3, our 2 factors that we got? Well, notice x plus 6, if we set that equal to 0 and solve for x, we get x equals negative 6. If we take x plus 3, if we set that equal to 0, and solve for x, we get x equals negative 3. When you plug a value into a function and it is equal to 0, that x value is an x-intercept, or a 0, or a root. We have multiple terms of calling it. So one way that you can always find your roots or find your x-intercepts is by taking your factors and setting them equal to 0. Factors being like x plus 6 and x plus 3. So once you set them to 0, then you just solve for x. So like as we look here, if we have two factors, x plus 5 times x plus 8, what we do is we set each of those equal to 0. We solve for x. So subtract 5 from both sides, you get x equals negative 5. For x plus 8 equals 0, you subtract 8 from both sides, you get x equals negative 8. So factors are x plus 5, x plus 8. Roots, or zeros, or x-intercepts, would be x equals negative 5 and x equals negative 8. So then when we go ahead and continue here, for x plus 7, x minus 6, all you have to do, it's already factored out, meaning there are factors shown. You just set each factor equal to 0 and solve for x. So we'll get x equals negative 7 here. On the right side, add 6 to both sides, we'll get x equals 6. And you may notice that your factors, these numbers, end up being kind of the opposites of what these roots end up being the opposites of your factors. So x plus 7 is a factor, x equals negative 7 is our root, or our x-intercept. Kind of interesting. But that's only the case whenever you have x plus something or x minus something. If it's like 2x or 3x or 1/2 x, then no, it doesn't work. For the last one here, again, it's already factored out, so what we do is we set it equal to 0, set each factor equal to 0, solve for x. So we get negative 4 there, add 5, we get 5 there. Not too bad, huh? Okay, so let's talk about what we mean by these x-intercepts. So x-intercepts are essentially values that make your function equal 0. So like as we take these x-intercepts, and that's what all these x equal pieces are, if we take them and we plug them back in, they should make the whole thing equal to 0. And we can always find those through the process of factoring. So as we look here with questions 1 through 3, our goal here is to factor them so that we can find the zeros or x-intercepts or roots. You're going to see all three of these terms used synonymously. So what we do then is we start by factoring. So factoring means look for what multiplies to C, what adds to B. So we have to think about what numbers multiply to 21 and add to 7. Those two numbers would be 7 and 3. So these are our factors to find our zeros, x-intercepts, or roots. You set each factor equal to 0 and then solve for x. So in this case, subtract 7 from both sides, we get x equals negative 7. For the second, subtract 3 from both sides, we get x equals negative 3. And these would be what we'd consider our zeros. Okay. All right. Number 2 here. Again, so we start by factoring, so think what multiplies to C and adds to B. What multiplies to 10 and adds to 7? That would be 5 and 2. So then so these are considered our factors. So then we set each factor equal to 0 to solve for x. Subtract 5 from both sides, we get x equals negative 5. Subtract 2 from both sides, we get x equals negative 2. Okay. Same thing here for number 3. So to find the zeros, we start by factoring. So look for what multiplies to negative 21 adds to negative 10. Might have to think about that one a little bit. But you should get negative 12 and 2. So set each factor equal to 0. X minus 12 equals 0. X plus 2 equals 0. So you get x equals 12 and x equals negative 2 when you go ahead and solve for 0. So we're taking what we learned yesterday with factoring, and we're taking it a step further. So once you have your factors, once you've factored looking for things that multiply to c and add to b, you set each factor equal to 0 and solve for x. And those are your zeros or x-intercepts or roots. Okay. Let's continue with a few more here. So we'll do 3 more together, then I'm going to ask you to try a few on your own. So here, x squared plus 6x plus 9. So we're looking for numbers that multiply to 9, add to 6. Those numbers would be 3 and 3. So those are our factors, so we set each factor equal to 0, x plus 3 equals 0, x plus 3 equals 0, solve for x. You get x equals negative 3 for the first, because you subtract 3 from both sides. The other one's the same. You subtract 3 from both sides and get x equals negative 3. If they're the same, you don't need to write them both. You really only need one. It's redundant. You don't gotta have them both. Okay. Number 5 multiplies to 49, adds to 14. Those numbers would be 7 and 7. Notice a similar situation here. We've got the same factors, so you really only need to set one of them equal to 0, and you'd get x equals negative 7. The last one here, numbers that multiply to c, add to b. So in this case, x squared minus 9, so our c value is negative 9. Our b value is 0, because there is no x term. So we look for numbers that multiply to negative 9 and add to 0. Well, anything that adds to 0 is going to have to be opposite values. So like 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0, and so on. So a positive and negative. Well, we know 3 times negative 3, well, that's negative 9. So our values would be x plus 3, x minus 3. These are different. X plus 3 and x minus 3 are different factors. One's positive, one's negative. So in this case, we do want to set each equal to 0 and solve for x. So subtract 3 from both sides, we get x equals negative 3. Add 3 to both sides, we get x equals positive 3. Okay. We're almost done. Last thing we're going to touch on here is when your equation is not set equal to 0. So if you have something here like x squared plus 5x equals 14, notice it's not equal to 0. You need to set it equal to 0. You need to make it equal to 0. So what we do here is we'll subtract 14 from both sides. So we get x squared plus 5x minus 14 equals 0. And now we go ahead and do the same thing we've been doing. So you look for numbers that multiply to c and add to b. Multiply to negative 14 and add to 5. So those numbers would be positive 7 and negative 2. And from there, set each equal to 0. And solve for x. So you get x equals negative 7 and x equals positive 2. Okay. All right. So how many do we have left? You've got 5 left. Pause the video. Try those 5 on your own, making sure to set each equal to 0. Okay. We are back. So start here by subtracting 16 from both sides, so we get x squared minus 16 equals 0. Then factor into things that multiply to negative 16, add to 6, so that's negative 2 and positive 8, to which our factors would be negative 8 and positive 2. Over here, subtract 18 from both sides, so we get x squared minus 3x minus 18. Then we look for numbers that'll multiply to negative 18, add to negative 3, so those are negative 6 and positive 3. So then we set each factor equal to 0, and we should get 6 and negative 3 for our roots. Last 3 here. Add 10 to both sides, we get x squared plus 7x plus 10 equals 0. Since it's set equal to 0, we can factor. So we look for numbers that multiply to 10, add to 7. So those would be 5 and 2. And our roots would be negative 5 and negative 2.
Second to last, we add 11x to both sides, so we get 12x squared plus 11x plus 24 equals 0. Notice I put it in A, B, C form, x squared, x, then just our number, just because it matches quadratic form, so it helps me remember that 24 is C, 11 is B. So we look for numbers that multiply to 24, add to 11. That'd be 8 and 3, to which we should get negative 8 and negative 3. Lastly, add 13x, so we get x squared plus 13x plus 30 equals 0. Factor it out into x plus 3, x plus 10. Set each equal to 0, solve for x. We get negative 3 and negative 10. And there you have it.